Good morning and welcome to the CADclass Podcast. I'm Josh.
I'm Jake.
And that is Connie. Connie,
We have a special guest.
Really, really nice to have you. For those of you who don't know, I'm going to give a brief little intro from the Discord to Connie. Connie is one of the ones that has been sharing her progress as she goes and showing off all of the challenges. And we have been blown away by your challenges. And also, there's been a big teaser. You've been working on a project. Nobody really knows what that project is. So, Connie, it is a pleasure to have you. Thank you so much for joining us on the pod.
Hello, everyone.
So
good morning,
this is Connie's first time on a
afternoon,
podcast.
or evening, wherever you are.
Yeah.
I know
So
we don't know how to
Connie's
handle that.
Yeah. That's a good point.
Yeah,
We need
it's
to do
like
a Truman Show.
Good something. Good night, good evening. I don't know. Wherever you are.
I hope you're doing
Good
well.
that.
That's fine.
Connie, so if you wouldn't mind, can you give us a little brief intro? Who are you? Where are you from? We'd love to know a little bit about you.
How'd you find
in the
us?
beginning. How'd you
All that good
find
stuff.
us? Yeah.
Yeah, my name is Connie, as said. I'm 44 years old, coming from Germany, North Rhine-Westphalia, a little town near Cologne. I'm married with my beautiful husband, who have no child. I'm working at an independent family-owned company, which is founded in 1452, which is a really, really long history. And we are
And it's still family
nowadays.
owned?
Hmm?
Wow,
Sorry?
it's still family
Yeah.
owned? Wow, that's
Yeah.
fantastic.
And nowadays we are a global provider of non-ferrous metal rolling mills and world market leader for foil rolling mills. And to give you a rough estimate, our mills can roll down to a minimum rolled thickness of 0.0045 millimeter, also 4.5 micron. And for example, if you have an electric car, then it's likely that the battery use the condenser foil, which is rolled on our rolling mills.
Oh, wow. I do drive an electric car, so thank you very much, Connie. I appreciate it.
And
God, that's so fantastic.
in this company, I'm working in the life cycle support department as project manager. I'm responsible for the commercial processing of our orders and therefore, all kind of filter systems, let's say. But more and more, I get deeper into modernization projects, also for rolling mills. And this is one thing that I want to get a deeper view into the technical area to gain a better understanding, let's say.
When we talked,
And,
when we talked before you got on, when we were talking, that's one of the things that was really fascinating. So you were kind of non-technical originally. Okay, so you were
completely.
non-technical originally, which I think is really interesting for our audience because a lot of folks come in here.
That really surprises me.
I put this in quotes because when you see what Connie's made, you're not non-technical. You're obviously very capable of these technical skills, but you came in because you were selling and you were involved in communicating with people. And if I remember correctly, you said, I just want to understand this process better to be able to have more fruitful conversations with the people that I'm chatting with. Is that right?
Yeah. The problem is that I mostly are in technical discussions and I can write it down, but I need to understand it also. And there it's better to get a deeper view. So
I love it. So, Connie, we've got the comments going off. People are really, really hyped to see what you've made. So I think we teased this a little bit too. So you're definitely going to show off what you made. And also you're going to talk a little bit about the process you went through to go from something not originally designed to be made on a 3D printer to translating it to be actually making it on a 3D printer. And as we were talking, and by the way, for our whole audience, Jake doesn't know what it is either.
I don't know a single thing. They've been talking for the past half an hour before we got on.
That's right.
Just so vaguely.
Yeah.
I've got no idea. We've all seen what Connie's been making on the Discord, and it's really complicated and very threads and this and that. And I've just been looking at it for like weeks, going, I've no idea what it could possibly be. I mean, it could be a million things in my mind, and the entire time, every single time Connie's brought up the thing, I've just been doing that. So I genuinely have no idea what you've been making. But I think we're going to be talking quite a lot this week about how you are going from a relatively basic source of information from like 2D sketches into 3D model and the entire process of that, which is tremendously important in the world of CAD. But I think it's even more important when you have that kind of physicality. It's part of your job where you go, I need to translate this into not just a CAD model for fun, but it's actually important for my work. I think that's way, way, way more important. So I'm really excited to see what you've made.
All right, Connie, take it away.
It's a question if we are talking before a bit how to come to it. So I think this describes it a bit more. So
Definitely.
when you keep my company history in mind, this is the moment where this 3D printing comes into play. And first time I realized 3D printing was while geocaching. And you maybe know that German people are really crazy, and especially when geocaching, we have the craziest ideas.
Oh, really?
And I found many, many really cool geocaches, and I said, this is so fascinating and so amazing, and I want to do this by myself. But the problem was that I didn't know anybody who had a 3D printer so that I can try it. And their coincidence helped. And
You've only
I
just
visited.
reminded me that the first time that I ever went to Amsterdam, every time I go somewhere new, I try and do geocaching, and I was literally right in front of the Heineken factory, and there was this lovely old fantastic bridge, and I knew there's a geocache on there somewhere, and I was just kind of walking around casually, trying not to drag too much attention, and I just saw this elderly lady doing the same thing, just kind of looking casually, looking both ways, hand behind the bridge, nothing, moving on. I'm like, I know exactly what you're doing, and she was German, and I didn't speak German at the time. I still really don't. And it was and I just kind of showed a geocache app, and she went like that. We couldn't communicate whatsoever, but we just ended up wandering back and forth along this bridge, and very, very strangely, kind of pseudo communicating about geocaching without any verbal understanding of each other. And it was really lovely. It was very kind of hands across the world. And so as soon as you say, oh, Germans love geocaching, just immediately brought me back there. I was like, oh my God, yeah. Yes, I know.
It's amazing.
Yeah.
So you were saying that's... Sorry, go on.
As I said, coincidence helped, and I visited Works Council conference, and there was one forum from our local Fab Lab, and they introduced their work and showed that you can come to them. They have one day in the week open for public. And you have access to 3D printers and so on, and really cool other stuff. And then I went there, and the first thing I ever printed was a cryptex. And it took me weeks to print because I can only go there one day a week. But after that, it was clear I have to buy my own printer. And in September 23, I bought my Bambolab P1S. Yeah, and then everything started, and I want to do, after printing the normal stuff, let's say, I want to build my own stuff. And then they told me at FabLab, okay, Fusion 360 would work for you and have a look at it. Then I tried to start learning with YouTube, but this didn't work for me. And then I find your book at Amazon, and yeah, it blew my mind because it was everything that I want for the concept, because it's this combination of lesson and challenge, together with the Discord, where you can ask, where you can share your results, and also the podcast. And yeah, this was so cool. So that yeah, I'm still going. Currently, I'm at chapter 9, the Edison bulb, and yeah, but this is totally fine for me. So I take my time. I stop after the lessons and practice the learned things. And yeah, this is the major reason I really like these challenges,
That's
to
amazing.
get
So
deeper into.
so can you start to take us through a little bit about what you're working on? I want to see it. So
This was wrong. Moment. um,
I'm so curious.
dun da da da. All right. I'm gonna blow this full screen up. So we can stop this and pause this as we go, Connie. Feel free to take control.
So I'm seeing dovetail joints.
This was one challenge for me, because the base plate is 400 times 350 millimeters, and this doesn't fit on my print bed. So I had to find a solution to to cut this in several pieces.
This is fantastic.
I just love this video too.
So all those blue pieces in the plate before, those were, in woodworking, we'd call those bow ties. Gosh, so many pieces. How long did this take you to print, Connie? All the individual pieces?
60 hours total printing time. But yeah, it's a lot more because of preparation time, and also some parts I missed to print it correctly in the first instance.
And how long did it take you to design all these parts?
This is an model which is used from for our trainees in the workshop.
Oh wow!
I think I can stop a moment. We have a training workshop. We where we train young people for becoming industrial mechanics. And one of their projects is to build this rolling mill, this model, with metal, and do their machining, and so on. And I saw this model many years ago, and I loved it the first moment I saw it, and I want to do this by my own, but it was not possible for me as a commercial. And this dream was way back, and now I had the idea to redesign it so that I can 3D print it. And this is the result of it, let's say.
I love this so much. And we're going to dig into the details of how you went from 2D drawing to 3D model, and then what challenges you had to solve with 3D printing. But yeah, let's keep this video flowing. Yeah.
God, I love all these assembly videos so much. Actually, assembling your first big 3D printing project is always so satisfying.
It's so satisfying.
Gosh, all the individual components. Oh, I'm just giddy to make a really big project now.
Totally. And which part of the assembly are we working here, Connie?
This is the mill stand. So you can the blue part is the mill stand itself, and you have the roll chocks and the setting cylinders.
So this is to recreate essentially a larger full metal bit of machinery, correct?
Yeah,
Fantastic.
that's right.
To the point where Connie had to ask her boss permission to even show it off. Like, hey, can I even do this? Is this? And they said yes. So thank you to Connie's
Oh, that's
boss.
fantastic.
So here you see the work rolls and the backup rolls.
Oh, that is so cool. Lovely videography.
Lovely. Lovely. For those who were
Oh,
just
this is so
listening in,
cool.
we are watching the assembly of Connie's project, and Connie will show it off as well. So sorry if you're not getting the visuals. If you're just listening in, definitely come to YouTube to see the visuals.
This is just so impressive.
How many different individual parts, Connie?
I think 40 parts that I redesigned.
Gosh, that is so
And
crazy.
in total, 200, 250, and with all screws and so on, including heated inserts and
Those are some of my favorite tools of all time. The heated inserts are so satisfying to use.
They really are.
Oh my gosh, I absolutely love this. I think we should send this to CNC Kitchen, who's also a German 3D printing enthusiast who
Oh, he
who would
would.
absolutely adore this. Oh my gosh, this looks like so much fun. How was the assembly fairly easy to do, or did you actually get to a point where you're going, oh gosh, this actually is quite complicated? How many bits are there?
no, this was no problem. So
I've done quite a few assemblies where I go, oh
the
gosh,
difficult
so many
thing was
parts.
this pressure rings because I don't have the right tools at the first moment. So it was horrible. Afterwards, it was totally easy.
Which tools did you need?
The
The
pliers?
yeah, that special pair of pliers for the retaining ring.
Yeah.
Mhm.
Yeah.
I've got one of those, and I can never find the ones with the prongs that have the right hole size ever. Gosh, so many more pieces, Connie. This must take you absolutely forever to design.
As I said, I only redesigned. Also the major part was I took the 2D drawings and recreated it in 3D. And afterwards, I changed the 3D design so that I can print it to use heated inserts and so on.
Wow.
I just love this model so much.
Oh my god. So are you planning on just keeping this for the education of your company, or are you planning on selling this as a product?
No, as I
Look
said,
at
it's
that.
a training model, and our trainees do it during their apprenticeship.
Oh, that is so fantastic. 2 kilograms of
Here you
material.
have.
Look at that. Look at that. And that's 60 hours of print time, by the way, on a bamboo. So
Yeah, that's a fast
you can
one.
do the math if you've got a slower printer. That's gonna be a
That's
long time on an
weeks of
ender.
printing. Yeah.
Long time on an ender.
Oh my god.
How cool is that? So Connie, I would love to. That's the end of the video, correct?
Yeah.
I would love to see it. I would love to see it. Can you?
Um,
Let's see if we can.
yeah.
Let's see the physical model. Dun, da, da, da. We'll see if this if the blur background works to not blur it out.
Gosh.
It doesn't
Yeah,
work.
a little bit.
It does
God,
a
that
little
thing's
bit. Are
huge.
you able to turn off the blur for just a second, or is that
Um,
a possibility?
let's check.
It's just too cool. It's just too cool.
God, that thing is huge. Wow.
Mhm.
Gosh, that's so fantastic.
And so basically, Connie, all of your Fusion experience was learning from our book?
Mainly, yeah.
Oh my goodness. Was there anything that you had to do that wasn't covered, or was basically everything there?
Mostly when I dive deeper into the challenges, then I combined your book with YouTube videos, because then there was the possibility to search for a concrete topic, let's say. And so the combination was quite good.
I think of all the challenges that I've seen you do, Connie, or of all the challenges that I've seen anyone do, every single time that I see you post one, I always look at it way more intensely because I know you put in so much extra detail all throughout it. Like the can opener is still one of my, I think one of my favorite challenges that someone's done because it includes so many different, really lovely mechanisms, so many really fantastic little details in it that I absolutely love every single time that I see Connie posts. I'm like, ooh, it's gonna be good.
I know. I love it too. I see it pop up and I'm like, okay, what are the details going to be? So, Connie, I think, and what we were promising to the audience a little bit, and what I really want to dig into for the kind of the remainder of this episode is, can you walk us through how you took something that was originally designed to be made in metal with metal machinery, and then translated those two-dimensional drawings into three-dimensional parts that can be 3D printed? What was the first part that you used? How did you actually go about doing that?
First, I thought about what is possible with my 3D printer. So the bed size was most important. Which parts can I build in the same size than already existing? But the larger parts, as I said, luckily only the base plate. I had to find a solution how to cut it in pieces and combine it. And I had also to decide what do I want the prints, let's say in raw form, or will I paint it, or something like this, so that I had a possibility to fill the gaps and sand it and afterwards paint it. And I decided no, I want it in raw form, and so I had to find a solution which looked hopefully good.
I think
So
it was
So
fantastic.
for the solution for the base plate. So you said one of the first things you had to solve was actually, how do I print this in multiple pieces and put it together? So how did you come up with that solution? And was it something you designed in CAD? Was it something you used the slicer software for afterwards? What did that
No,
look
I
like?
designed in CAD. So I first designed the part itself as it was in on the drawing, and then I decided what is the best cutting point, let's say, because I don't want it would be possible to only cut it in 4 parts, but then I had directly in the middle of the mill stand, I would have the cut, and I
Mhm.
don't like this. So I decided to split in 6 parts so that it is created. Let's see if I can show you in the model.
Yes.
And on the
Yes,
model as
yes.
well, so I saw that you used just dovetails that were kind of built into the plates to lock everything together to index it. But then you also put in those blue bow tie pieces, and I was a little curious why you did both. Gosh, look at that timeline.
Because I
Look at
think it was a
That's the
nice
timeline.
detail.
what was that, Connie?
It was a nice detail.
I agree. I think it's lovely.
So I mixed it up. So first here you can see it. Oh,
Yep.
Mhm.
I decided to split on this point so that I have not the cut in the middle, and here it is covered with the foundation crossbeams, and therefore I only used the dovetail in this direction, and on the other parts, I just use it in this
Josh,
way.
I don't know about you, but I have this very this very strange sense of pride that
Yes, this is amazing.
that I obviously this
amazing.
is all Connie's fantastic model, but I do have this sense of look at what we've done.
Yeah. We did. Yeah.
It's
Connie,
like,
this is
look at this amazing painting my kid made.
Yeah, this is so impressive. Okay,
This is
so
so elaborate.
so the base plate, you cut it into 6 pieces. When you originally designed it, Connie, was it 1 piece and then you had to cut it up into 6?
Yeah.
Okay. And how did you cut it up into 6? Do you remember what tool you used or, any of the technical details? No big deal.
I think I projected this line onto the base plate so that I have an dimension which I can use, and this is only the half, and then I try to recreate the dovetails.
Gosh,
So
this
if
is
you
just
So you
looking-
reference the geometry of the piece above it. So you built the base plate,
Yeah.
you built the rest of the model on top of it, and then you made that decision later to cut it up. And when you did that,
Exactly.
you just referenced the geometry above it. Interesting.
Now, Connie, I do have a question for you. So I think one thing that a lot of people run into when they get into 3D printing is that they make a big project like this, and then they get into this default mode where they go, oh, every piece needs to be 3D printed. And coming from this, I know that because you have quite a large bit of material, I can imagine some people in our audience are going, why did you 3D print the base? Why didn't you just use like a piece of wood or a piece of plastic? And I want to know your reasoning, because I have a suspicion that it's because the location of the holes and the threads and everything like that needs to be absolutely perfect, or else it just won't work. But I was wondering if you had any other insight why you decided to 3D print this, other than make it out of just a normal sheet of plastic.
Simply because I want to build this completely from 3D as a 3D
Just
print.
the challenge?
So, yeah.
That's a way more of a hardcore answer than I was expecting.
Yeah, it's amazing. Okay, so you've got the base plate, you're building up component by component. As you started to work on this, what was the first real stumbling block? What was the first challenge that you ran into and you thought, I'm not really sure what I need to do from here?
Oh, the parts itself, the 2D to 3D was relatively easy.
Oh, really?
Because
Wow.
these are not that big complex parts. The complex part, I think, is this mill stand. So you have small parts which you can create. The challenge for me was to decide how to create them, because 2D and 3D are not the same way to design, let's say. And so the decision, will I, for example, rotate this coil so that I get the shape, or will I don't know, draw a ring and expand it? And but mostly this was clear. So it was a straightforward work. Afterwards, I had to learn a bit about 3D printing, because the heated inserts I have to include, so I can't use the original measurements from the boss. And I had to redesign this, and at some point they result in collisions because you need more space than in the machined part. And therefore I had to, for example, here you have one screw here and one screw here, and on the other side you have the roll which comes from here. And the problem was that the heated insert was that big that it collided with this roll, and so I had to rearrange it.
I find that, especially for these large mechanisms, it cannot be understated just how many times you often need to go back and redesign and very iteratively approach CAD modeling, because nobody has ever made a model as complex as this in one go. It's just never happened. And I think people coming into it going, oh gosh, it has to be perfect the first time. It's completely not true. You are always going to be going back and changing things, swapping out components, swapping out hardware in your case, and that will trickle through and change not only the design but also the individual components themselves, which is coming through completely on this.
And so I've asked a handful of folks in our community to ask some questions as well. So Connie, if you don't mind, I'm gonna ask a few. Excuse me. Apparently there's a frog in my throat. I'm going to ask a few technical questions, and then I'm going to save some of the larger ones for a little bit towards the end. By larger, I kind of mean like, what was the biggest thing you learned kind of stuff. But technical ones, we had a couple of good ones here. One of them was, tell us about the infill and perimeters. So tell us about, how much are these solid parts? How did you go about thinking about the 3D printing side of it?
I used the, let's say, standard tools. I only used 2 outer walls, and I think 15% infill, sometimes up to 30. But mostly this works totally fine. So one thing that I realized after I printed all, but it worked out luckily. I find out that the heated inserts normally need, yeah, how can I say it? Thicker walls, yes. And I found an idea which I find really great to only locally apply a thicker wall around these parts, but I don't use it here. So,
Which slicer
but it
did you
worked out.
use? Which slicer did you use?
Bamboo slicer.
Bamboo slicer. Oh, that would make sense because you have the bamboo. So you didn't end up using the thicker around that for the heated insert, you said?
No, I only used the normal wall size.
Wow.
This is the build plate, let's say.
Wow. This is amazing.
God,
We had another question. I wondered how the clear dome was made. Was it vacuum formed impressive piece?
This is the only part which I get from my company, as this is also a an purchase part for all our machined models.
So is this a 1-to-1 replica?
Yeah.
Oh, it's
in size.
In my mind,
wow.
I was thinking it was like a gigantic
Me
machine
too.
you'd scale down.
Yeah.
Gotcha. All right.
Wow.
It's only a model for them to learn how to work accurate and so on.
So maybe we could do here briefly, because we promised that we would do this for some folks. Can you talk us through a 2D drawing? I know we've got one in the Discord that we could show off that's not related to this project, so we don't show off the IP. But I'd love to just hear you talk through a 2D drawing and maybe how you would translate it into 3D. Is that something you're up for?
We can do. I can try.
Yeah. And it doesn't have to, you don't have to necessarily do it on screen, but I'm just curious, like, how are you thinking about it? What you kind of just mentally walk us through the process you would go through, and then also translate it from, if this were going to be made out of plastic as opposed to metal, here's what I would consider. So I think it is on the Discord. We had a piece that is not too crazy. Do you see that one on there, Connie? Do you want me to share my screen?
Yeah, go ahead.
Why don't I share my screen? Share screen. No, we have to do the entire screen. That one. There we go. And it's going to be something like this. So, well, that's not as big as I was hoping it was in the screen.
The zoom is smaller than the actual image.
What? That's not what we want. Okay. Well, sorry, everybody online. That's hard to see. Maybe you could just walk us through something visually. This is technical difficulties on the Zoom on this one.
Yeah,
So something
I'm
like
not
this,
quite sure.
yeah.
I'm not quite sure how I would do it. I think it's not a part which you rotate in total because of this flower shape, let's say. So my attempt would be to create the flower shape and extrude it. And afterwards, you can go on the front plane and create this. I don't know how to describe this.
It's
The,
pretty
Um,
tough, yeah.
the round part, let's say, by rotating.
I mean,
Yeah.
this is. I mean, this
This is a
problem that we're
weird
having
model.
right now, where it's hard to communicate this, is exactly why engineering drawings are so important. Going up to someone and saying, "Oh, can you make me this?" It needs to have a flower design for a handle and a pipe and then a cutout. And even if you tell them all the dimensions, it's almost impossible to actually get the final part that you need. And having an engineering drawing like this is hyper critical. And even more so, having or having that kind of design information or manufacturing knowledge as well to back it up and going, this needs to not only convey all the information but also be easy to read, not complicated, because every single time that an engineer or a CAD designer hands over a drawing like this to a manufacturer or a machinist and they have to go back and forth, that's a huge amount of inefficiencies that kind of gets built up in the system. So designing with a certain degree of manufacturing knowledge to back it up is absolutely critical. And unfortunately, that isn't always the case in the industry. I've heard so many stories of machinists and technicians that go, "Oh gosh, I can't stand engineers because they'll design something that physically can't be made in real life." And he's like, "Oh god, I have to go back and forth," and it just takes all this extra time. So did you actually make this drawing, Connie?
No,
Ah.
I
So,
don't.
No,
This
no,
this was
I was
only
sharing.
an
I just shared that.
example.
Yeah, I was just sharing
Yeah.
that on the Discord. I didn't want to have stuff that
Oh,
was
yeah, that's right.
IP for the company kind of displayed.
Gotcha.
So I was trying to find something that was useful. Sorry, y'all. That wasn't so useful.
Fair enough, fair enough.
But it's an interesting challenge, so perhaps.
I totally agree, yeah.
So what was the hardest part about translating a model that was originally made in metal to an object that you can 3D print? Was there one object? Was there a roller? Was there something about this project that you really had to think about how to print it, make changes?
Mm, most things are basic stuff to learn. So for example, I had to learn that a ball in 3D printing is not a circle. So
Yeah, it's not
it
really gonna work.
depends on if you print it on the bed or if you print it horizontal. So that you get an oval shape, and you have to take this into account, and you have to make this balls especially bigger. And so mostly it's about how to position the parts on the print bed. I tried to. I have a pie plate, a structured plate for the bamboo, and so I tried to place all outer surfaces on this build plate so that I have a smooth finish. And because of this, you have to look at several points. For example, on the top of the mill stand, I have these setting cylinder. And I realized afterwards that it is not necessary to completely design it in the way as it's designed for the machining. because for the machining you have to drill from the outside of the mill stand to get the bore in the inside. And this is not necessary for 3D printing. So I decided to close the top and only build this hole for the setting cylinder as deep as it must really be. And these are such things. Also, the bottom setting cylinder. It is. I can show you. It's better to explain.
Yeah, I'll share your screen again.
Knowing the advantages and disadvantages of 3D printing versus like traditional machining is so critical.
Well, it sounds like too, you're talking a little bit about print in place. That's kind of the style, right? Like a part inside of a part that you couldn't do with classic manufacturing techniques.
So for the machining,
I can't see your screen, Connie.
Oh, sorry.
It's all good. There we go. Go ahead and add it. There we go.
Okay.
I just love this model.
So this is the, let's say setting cylinder. It's more complex in real, but you have the setting cylinder, you have the nut, and you can see this.
You can isolate that component, Connie. You can right-click it and isolate it if you can figure out which one it is in the browser. Yeah. I don't know if you can isolate it. Can you isolate it directly from clicking the component?
No, you can
from the drop down. Yeah.
So it's the dash in the browser right in the middle. Yeah, you can expand that. And then which one is it? You can there you go. Isolate.
There we go.
Good thinking, Josh.
So you have this I don't know the word.
Kind of groove that's cut through it, do you mean?
Yeah, thank you. And this is because the cylinder shall stay in place. Also it should not rotate, but on the other hand, it should be moved up and down with this nut. And to do this, in the original model, it is designed in a way that you have a bore where you can put in
a set screw.
A screw, so that it is locked in place. And afterwards, I had the idea that it would be much easier to create, a counterpart for this setting cylinder, so that it has much more covered surface, let's say, and not only the metal screw, which will ruin it in the long term. But these are things I believe can be done in 3D printing in a better way.
That's
I
amazing.
don't think so. I think this is a phenomenal design.
So cool. I have a couple more questions here coming in from the chat that I wanted to get to. I had a funny one. Why not design printable adjustable pliers for the E-rings? So why didn't you print the tool itself? Which is I could go off on a tangent, but I'm curious, Connie, why did you decide to buy one as opposed to make it?
Was easier.
Yeah. Not everything needs to be made. That is exactly my point, right? Like screws, you don't need to make all the screws if you have them. So that's funny. And then
I like we're doing that as we're 3D printing a 3D printer.
I know. We don't even take our own advice. So then PC Van Vliet, Mr. Mitnick, one of our moderators, always good to have him here. He says, what's the number one thing that you learned from this project that you would like to share with everybody here?
Keep going.
Oh.
That's pretty good.
So, and a good challenge, is let's say everything to success, and have a good feeling to go further.
That's so good to hear.
That motivation to keep on pushing when you're working on a gigantic project, there is some kind of relief in knowing that, well, this is going to be a project that I'm going to work over the next couple of years or maybe a few years. Beforehand, Connie and I were talking about the R2D2 project that I've been having on the back plate for a while. Connie also wants to make her own 3D, her own R2D2, which is a very noble challenge. So I'll probably be sending over some files, but it is for these huge projects, it is not easy to just continue to keep on going for so long. And I've got a bunch of projects that are half finished, just kind of rolling around all my folders, and keeping going is pretty good advice, I would say, especially for beginners.
I have a question. Speaking of keeping going, what would you estimate was the time it took you from idea to actual made part?
I don't know.
Like months?
Yeah, 1, 2.
Were there any points
One
that you said?
goal, I think, was to show that it's possible to do it.
So was this a part that someone in your company said, "Oh, Connie, can you please make this for us? That would be super duper useful." Or did you just go, "I have the skills, I can make this. Let's go."
I discussed with our design trainees, and they said they started to print and they don't finish it. And I want to show that it's possible. But on the other hand, it's, as I said, it's one dream to have this model. And now I can take it with me in the office, and it's there.
And just show it off. Do you have your name on it?
No.
Oh, you need to sign it. You need to sign the underside.
There needs to be a signature on there. That's There's
Don't
no
forget
better.
who made this.
That's one of Jake and I's favorite things, about what you're posting on Discord as well as other folks, is just showing people that it can be done, even if it's only the projects we're doing, but especially when it's those projects that you end up doing on your own. I think Jake and I are planning to put projects in the next book because we just want to show people it's possible. And there's no better way. And what I love so much about your project is there's no better way to show it's possible than by just showing the thing. Here it is. I did it. I didn't have experience before I did it. And here it is. So I love that, Connie. That's so cool.
God, that is so fantastic.
So Dan says, was it done on the company clock? Oh my goodness. That's
No.
I'm sure it was not.
Totally
if the bosses chime in, they're like, was it done on the clock there, Connie?
Give me 2 months. I just need to make this real quick. It'll take no time at all.
Samuel says, how important are CAD communities? Did you find our community helpful when you were doing it? And if so, why?
Absolutely. Because you have the exchange of thoughts, and you can ask questions, and you get motivated. So I think it's very, very important.
Yeah,
that's one of the major things that I love to hear is people seeing other people's projects and going, "That's rad. I want to make that as well."
I have a question about the mechanics. So as you're making this model, how much more of the mill did you understand because you had to actually physically build it? Or did you already understand it and this was just for fun?
Let's say this is for fun. It's a cool start to get deeper into the topic, but it's only absolutely basic. So up to now, this is a level I understand. So say so.
One thing that I'm quite curious, Connie. So you're saying that you certainly did go to YouTube to learn some extra information to kind of fill in the gaps. But you said the majority of but you said the majority of what you learned from CAD was through our program. And I wanted to know that this is obviously a very, very complex model that requires a lot of organizing, a lot of knowledge about how the tools work, how the parts are assembled together. all the stuff that goes into large projects like this. And I'm curious to know from you, obviously, if you went through the entire book, you'd have a ton of information. But for most people, we find they don't need to go through the entire book to make their projects. We've heard from a lot of people where they just have a simple design in mind, where they only need to do maybe the first couple chapters, and then they have enough information to really get going to work on their project, where they go, oh, it's actually not all that complicated. And I may continue the book just to learn more about CAD. That's cool. But how far into the book do you think that you needed to go to actually make this?
Not far. I think chapter 2 or 3.
Wow.
So the first models that I created were directly at the start.
Gosh, that's so impressive. So everyone who's working through chapter 2, you now have to build something as complicated as this. This is your challenge for the week.
That's right. That's right. So organization, I want to double click on organization for just a second. So I noticed that you had your components nice and organized. How did you figure out how to organize this?
I organized it in the way the company organizes it. So it was not that difficult to decide.
So for example, each component that or each individual drawing was a separate component, and you just knew, I'm going to make this drawing a component, and they're all going to be nested under the major assembly file.
Yeah, so we have assembly groups, and in each, so for example, what can I show?
You'll have to share your screen again too.
Yeah, I try to isolate first.
She's got secret stuff. She's got to be showing everything.
No.
Definitely.
I think one of the major things that people need to understand before they dive into a big project is making that really, really solid organization of the components and of the assemblies right at the beginning. Because if you get halfway through it and then you go, oh no, these need to be in the opposite orientation, or these need to be groups and these need to be separate, it's almost it's more time efficient to start from scratch than it is to rework and reorder and reposition things, which is crazy, but it's completely true.
So what are we looking at here, Connie?
So this is one of the assemblies. This is the entry side, and yeah, when you look at this, you can see all the components of it, and yeah, my problem was most times I was organized because of the already given assembly structure, and then I just forgot to switch between the top
assembly
design.
file.
Yeah, and the exact assembly file where I have to be. Yeah, and it was a mess. So I done several things twice.
So to Jake's point, you had to just redo it.
Yeah, which is totally normal. One thing that I just noticed that I want to point out to the audience: this is obviously a very, very, very large project, and if you look at Connie's timeline, all the components are put into groups. So all the different features that are all incredibly organized and all compressed, and that's lovely. And I just now noticed there is still a scroll bar on it. So even if you compress every single feature that goes into making this into really organized groups, it is still a massively long timeline. There are so many steps that go into making big projects like this. And it's just mind-blowingly big. So Connie, congratulations. This is fantastic.
Absolutely fantastic. So I really only have one more question. And that question is, Connie, what's next? What is next for you?
Want to finish the book because I really, really want to build this lightsaber.
It is one of my favorite projects that I've ever made in real life. It's on my shelf of interesting things. yeah, so it is a project that comes right from my heart. So I hope you have a ton of fun with it.
Amazing. It has been absolutely wonderful having you on, Connie. I hope you all learned a lot. If you have more questions, Connie is on the Discord under the very complex name of Connie. you can find her on the Discord. So if you have more questions about this model or you want to chat, go back and forth, she is there. Connie, it's been a pleasure.
Many thanks for your invitation.
Absolutely.
Any final lasting words of wisdom, or shall we close it down? Keep on keeping on. I think you said it earlier.
Keep on
Okay,
going.
it's a pretty good finisher.
This has been the CADclass Podcast. Once again, I'm Josh.
I'm Jake.
And that's Connie. And we'll see you next week.
See you guys. Have a good
Take
one.
care, everybody.
Bye.